Hi everybody, this is Ryan, and I'm back for a video. This time we're going to talk a little bit about functions. Let's start off with basic functions. So we're going to start off with relation, domain, and range. A relation is a set of ordered pairs. The set of first components of each ordered pair is called a domain. The set of second components of each ordered pair is called a range. So the domain are equal x values. The range equal y values. A function is like a magical box that takes something in and spits out something else out. In math terms, it is a special relationship where each input, or independent variable, is connected to exactly one output or dependent variable. So if you feed the function a number, it will give you back another number, but it won't ever get confused and give you two or more numbers for the same input. Input, also known as the independent variable, are often x. Those are your domain. Output, also known as dependent variables, are your y, or your range. The domain is the set of all possible outputs, and the range is the set of all possible outputs. So domain is inputs, ranges are outputs. So here's an example. So identify the input values. So if we look at all the input values, they're going to be all your x values. This is 1, this is 1, this is 1. So those are your input values. The output values are your y values. These are your output values. If each input value leads to only one output value, classify the relationship as a function. If any input value leads to two or more output values, do not classify as a function. So if you look at this, does each input go to exactly this one output? Well, take a look at this one. Here's an input. If I input a 1, I get a 0. But next time I input a 1, I get a 5. So since this 1 goes to two different values, we're going to say that this is not a function. Now, one way to test this is using the vertical line test. The vertical line test is a quick way to determine if a graph represents a function. If any vertical line intersects the graph more than once, it is not a function. So here's a graph. So notice this vertical line, it intersects the graph once. So it's a function. This vertical line intersects the graph twice, so it is not a function. And this graph here intersects this graph more than once, so it's not a function. Let's talk a little about one-to-one. A function is one-to-one if each output corresponds to exactly one input. This ensures that the function has a unique inverse. Think of a one-to-one function like a VIP list at a party. Each name on the list gets you one and only one ticket. No name repeats, and no ticket can be used twice. Now, the vertical line test is used to determine functions. The horizontal line test is used to determine whether or not a graph is one-to-one. To check to see if a function is one-to-one, use the horizontal line test. If any horizontal line test intersects graph more than once, the function is not one-to-one. So which of the graphs is a one-to-one function? So if you look at this one, vertical line test, these vertical lines all work. So this last one is not a function. These two are functions. Now, of these functions, which one is one-to-one? So if we do horizontal line tests, there's here and here, here and here, 3 times. So this one would be not one-to-one, but this one, the horizontal line test only passes through it once, so it would be one-to-one. Now, function notation. If I have a graph of function like y equals x plus 1, we can change the y to f of x equals x plus 1. So in this case, y equals f of x. And what this is neat about this is you can say f of 2. That's the same as 2 plus 1 or 3. So all I'm doing is replacing the x with a 2 in my graph. Now, independent dependent variables in a function notation, x is the independent variable, the input, and f of x is the independent variable, the output. So notice, if I have a graph y equals x plus 1, and I change that to f of x equals x plus 1, if I input x equals 2, which means I have f of 2 equals x plus 1, that's the same as 2 plus 1 or 3, because I just input the 2 in for the x. And you can name these functions anything you want. I typically use f of x, but you can call it g of x, c of x, whatever you want to. But the big thing about this is that this x here, the x is the input. F of x together is the output. So if we want to evaluate these functions, so if I have g of x equals x squared minus 5x plus 6, I'm going to take g of x for 3. That means I'm going to input 3, we'll replace 3 for all the x's. Whoops. So we would say g of x equals 3, or equals 0. G of 3 equals 0. Let's try this last one. H of negative 2 equals 3 times negative 2 minus 7. That's negative 6 minus 7, or negative 13. Functions can be represented in tables, which can be particularly useful when equations are not based on best fit. Domain is the type of input, range is the output, often a real number. So if I want to find f of 2, so this is f of 2, and this is x. So if I have x is 2, I go over, here's the graph, it goes right there, and I go over to y. So f of 2 equals 1. Now this one I'm looking for x, so this is my y value, so y is 4. So there's y is 4, and my x is negative 1. So f of negative 1 equals 4. Now we have all different kinds of functions. Here's several of them here. Let's talk about linear functions. A linear function is characterized by a constant rate of change and can be represented by a polynomial of degree 1. Now when we say degree, if I have y equals x plus 1, the degree is given by this exponent right there. So this is degree 1. If I have y equals x squared plus 2x plus 3, this time this variable is a 2, so this is a degree 2. Now there's a couple of equations we want to look at. This is a equation form, and this is function form. Now when we're looking at a graph, we would say if you're going uphill, it's increasing. If you're going downhill, it's decreasing. If you're just constant, it would be a constant function. Now slope is equal to rise over run, or the change in x or the change in y. Change of y or the change in x. So if I want to find the slope of 2 points, I'm going to go, this is x1, y1, x2, y2, I'm going to take the slope is equal to 2 minus 6 over 1 minus 3 or negative 4 over negative 2 or 2. This next one, I'm going to go slope equals 4 minus 1 over negative 2 minus negative 2 minus negative 1, which is 3 over negative 1 or negative 3. Okay, to find the x-intercepts of a line, you let y equal 0. So to find the x-intercept, I'm going to find out where y equals 0. So this is where y equals 0. So this first one, 0 equals 2x minus 3. Add 3. So 3 is equal to 2x. So 3 halves equals x. So my x-intercept equals 3 halves. This last one down there, 3y plus 6x equals 12. Let y equal 0 and solve for x. So x is 2. So the x-intercept here equals 2. Now there's a few other formulas here. We have point slope. This is point slope form. Here's an example of using point slope form. A couple of examples of how that works. So if I want to write an equation of a line that passes through the point 2, 3 with a slope of negative 2, I'm going to use slope-intercept form. And you need two things. You need the slope and the y-intercept. So I have the slope. I need to find the y-intercept. So I'm going to do 3 equals negative 2 times 2 plus b. So 3 is equal to negative 4 plus b. So add 4. So 7 equals b. So this is x and this is y. And notice how I just plug things in. So my equation is going to be negative 2x plus 7. Now this next one, I have to find slope first. So 4 minus negative 2 over negative 4 minus 3. So that's going to be 6 over negative 4 or negative 3 halves. So once I have my slope, you got to figure out what b is. And you figure out b just the same way we did up there. Quadratic formula looks like this. Quadratic functions like that. Notice how they're degree 2. That acts as a symmetry. And that axis of symmetry is found by solving x equals negative b over 2a. This is the standard form of a quadratic function. The vertex is hk. So to find out the vertex, you're going to follow this step right here. So we know that this is ax squared plus bx plus c. That should be, the squared should be there like that. So I'm going to go for my h coordinate. H equals negative b, which is negative 4 over 2a over 2 times 2, or negative 4 over 4 or negative 1. That's my h value. My k is equal to evaluating my function for this value. So I'm going to take f of negative 1, and I'm going to plug that in. So my k is going to be equal to 4. So my vertex will be negative 1, 4. Here's some properties of parabolas. Take a look at those. Now, one thing we can do is we can shift them around. So if I have a parabola, the basic function of a parabola is y equals x squared. So xy, again, negative 2, negative 1, 0, 1, and 2. So it'll be 4, 1, 0, 1, and 2. If I want to move my parabola up and down, I add something to it. So if I add a 1, it's going to move it up 1. So if I do f of x equals x squared plus 1, it's going to be up 1. If I subtract 1, it's going to be down 1. If I want to shift left and right, if I have f of x equals x minus h, so if I go x minus 3 squared, that's going to be right 3. If I go f of x equals x plus 4 squared, that's going to be left 4. And if I want to compress it, if I make a greater than 1, it's going to vertically stretch it. If a is less than 1, it's going to compress it. So I think that's all we got for our video. If you have questions, please let me know.